Welcome back, guys, to another lesson on trigonometry where we look at today the concept of angles of elevation and depression. So let's have a look at what it is. So the angle of elevation here is the angle of looking up, measured from the horizontal. So basically, if you're a person here and you're looking up at that balloon right there, you're looking upwards. And that angle there to the horizontal, most importantly, theta, is what you call the angle of elevation. And what this creates is a right angle triangle right here that's right angled. And we can find all sorts of stuff such as the line of sight, what the horizontal distance is, how high the balloon is from the ground. Okay, so a simple way of actually remembering this is when you feel elevated, things are looking up. All right. Now, contrary to that, the angle of depression is the angle of looking down, measured from the horizontal. So if you're a person on top of some, I don't know, building or something like that, and you're looking down at the water and there's a duck there or some boat or something like that, you're going to be looking down from the horizontal. So if you're looking straight, you're looking there, but if you're looking downwards, you're looking this way. And this angle here is what you call the angle of elevation. Okay, so our way of remembering this is when you feel depressed, things are looking down, so you're looking down this way, and that is basically the hypotenuse of this right angle triangle that is right angled, okay, and that line that is from yourself to this duck here is called a line of sight. All right. Now these two angles are actually equal, okay. So I'm just going to add a note here. So if this is your angle of elevation, which is theta, then this is also theta, which is your angle of depression. Okay. So I'm going to write here that the angle of elevation, okay, is equal to the angle of depression. All right, so this angle of depression is this guy here, and the angle of elevation is this one here. Okay, and that's equal because these two lines are parallel, meaning that these two angles are alternate angles which are equal. All right, exercise 805. Let's have a look at the first question. Copy each diagram, mark the angle of elevation theta, and find its size. So make sure that you write and draw each of these shapes here very quickly. What you've got to do is find the angle of elevation. So in order to do that, the angle of elevation is the angle where you're on the ground and you're looking upwards. Okay, so which point here would be the ground? It will be this one. So if you're a person here, you'll be looking upwards, and this theta is what you're basically finding. So that theta inside this triangle is required to be found. And how you find that is by using the angle sum of a triangle. So we know that theta plus 70 degrees plus 90 degrees equals to 180 degrees. That's the angle sum of a triangle. Now these two angles, they add up to become 160 degrees, right? Then what we do is we subtract 160 degrees to both sides, and so theta would equal to 20 degrees. Okay, now let's have a look at question B. If I was to choose which angle here is our angle of elevation, where we're looking upwards on the hypotenuse, it will be this angle here. Okay, so you're looking upwards there. So that's theta. So to find that, given that this is 30 degrees, remember this is your angle of depression. This angle of depression here is equal to your angle of elevation. So these two are exactly the same. So we say theta equals 30 degrees. Same with this guy in question C. This is your angle of depression right there, which is also equal to your angle of elevation right here. So we say theta is equal to 54 degrees. Next we have question 2. Copy each diagram and mark the angle of depression theta and find size. So I'm just going to remind you that your angle of depression is always measured from the horizontal. So this is your horizontal line. Okay, so it's always this guy here, right? This angle here. So it is not going to be this one, okay? It's going to be this one here, because this one here is measured from the vertical rather than the horizontal. So please don't get confused. So this angle is not the one that you're finding. It is actually this guy, okay? And how would I find that? Given that, well, these two lines are parallel, we know that, they have to be, okay? And this is 90 degrees also, because of cointerior angles. These two have to add up to become 180 degrees, so that's 90 also. So how would I find out theta then? Well, theta has to be 90 subtracted by 41 to get that angle there, okay? Or you can write these two angles have to add up to become 90 degrees. So we can write that as well, if that makes sense to you. So they both add up to become 90 degrees, so that when you subtract 41 degrees to both sides, we will get these cancelling out. So theta would equal to 49 degrees. All right, let's have a look at B. So remember, we're looking at an angle of depression. We're looking downwards. So the angle that we're finding out is this guy here. So there is no way we're going to find that using alternate angles at all. There's no angle here. But what we can do is use the angle sum of a triangle here, which totals up to become 180 degrees. Now theta plus these two angles, which is 152 degrees, and that's equal to 180 degrees. Okay? Now if I subtract both sides by 152, then that would mean theta would equal to 28 degrees, right? Now let's have a look at C. The angle that we're looking for, measured from this horizontal line, is this angle here. That angle is simply alternate to the other angle here, which is 43. So I say theta equals to 43 degrees, based on alternate angles. Okay. Question 3. Sanku stands 800 meters from the base of a building using a kilometer, which is just a device that we can use to measure the angle of elevation or something. He finds that the angle of elevation of the top is 9 degrees. Okay, find the height of the building correct to the nearest meter. All right, so basically there's a person here with that inclinometer, and he's going to measure the angle to the top of the building. He measures this as 9 degrees. Now it wants you to find the height of the building. So that height is this one here. We'll just call that x because we want to find that. So now we're going to start pondering which trigonometric ratio do we need. So we know that opposite 9 degrees is our opposite side all the time. So we'll call that O, whereas 800 here, which is our base here, okay, is going to be our adjacent side because it's right next to these two angles, it's adjacent to them. So using Sokotoa, okay, which trig ratio do we use that has O and A in it? It is the last one. So that is tan of theta that we've got to use, and that's equal to the opposite, which is x over adjacent of 800. Okay, now once we have that going on, we can undo that division of 800 to solve for this x variant on top. Okay, remember you do that whenever the x is on the top only. So we do the opposite of dividing by 800, which is multiplying by 800. Do that to both sides. Okay. Oh, and also, you know what? Theta is actually 9 degrees. So let me just change that to that. Okay, sorry about that. So these 800s cancel. Then we have 800 equal to, sorry, x equals to 800 times tan 9 degrees. So let's type down our calculators. 800 tan 9 degrees is going to give us 126.70 and so forth. So if I round it to the nearest meter, it will be 127 meters. Okay. Let's move on to question 4.